Good evening, everyone. Welcome to the CodeRally 5.0, organized by the IEEE Computer Society Student Branch chapter of IIT. We're starting with an excellent workshop on advanced programming techniques, the fourth in a series of 6 engaging workshops. I'm Kavinti, and I'm thrilled to be here with you all today. Thank you for joining us. Today's session focuses on advanced programming techniques, where you'll learn strategies and methods that will benefit you beyond this workshop. Your active participation is key to gaining more knowledge and making the workshop enriching for everyone. Please scan the QR code on the screen to submit your questions and share your thoughts. We'll have a dedicated Q&A session later. And also, we have something very exciting for you. We're launching a swag challenge. All you need to do is write a LinkedIn post about what you've learned today throughout today's session. Don't forget to tag your post with the hashtag shown on the screen to enter the challenge when posting. We'll be picking the best post, and the winner will get some exclusive swag in our next session. So get ready to share your insights and join the challenge. Now, let's give a warm welcome to our speaker, Mr. Amod Sahabandu, who is an AI ML engineer at Altrium. He will be guiding us throughout this workshop. We are truly grateful for your presence here today and looking forward to the insights you'll be sharing with us.
So, yeah, thank you. You guys can hear me, right? Yeah?
Yes, sir.
Yes, we can hear you.
Yes, sir, we can.
Yeah, all right. So I can start now, right? Okay. Yeah. All right. First of all, let's get sorry, I'll just share later. So first of all, talking about me, I work as an AI ML engineer at Altrium. So Altrium is this company where we work directly with clients in the US. We work exclusively with clients in the US, and we design solutions using AI. That's the AI is our main part that we do. So yeah, so that's my background. So talking of my background, so I am a graduate from SLTC Research University. You might have heard of it. It's not that popular yet. So what I did there was I did electronics and telecommunications engineering. So then I transitioned into machine learning after I graduated. So I worked at InsightShare as an associate ML engineer, and then I joined Altrium. So what this session for me means is like this session is a workshop, right? So we are going to go. You guys are planning to go until 9:30. Is it the plan? Hello, you guys can hear me, right? Yeah. All right. So the thing is this, right? Yes. So yeah, the thing is this. We're today talking about like advanced programming techniques. You might be thinking, why should I learn advanced programming techniques? We have AI now. We don't need this or something like that. Or you might be wondering, what's the point of doing computer science at the moment with the industry? So I just wanted to start with that. So sessions like these are really important for you guys to expose yourselves to the industry. So we come here representing the industry. And if you guys can stand out at events like these by asking questions or by responding to answers, like responding to questions and being interactive, that would be really awesome. Because for your career, not for us, right? Because we are looking for people who can clearly communicate. We are not looking for people who can code, to be honest, right? We are just because you code, we are not looking for you now. What we need is we need you in a particular set of skills that is necessary for the industry, because you need to communicate with clients. You need to have the ability to conduct yourselves correctly. So that's kind of something that I wanted to say. So I hope, so what I'm getting to here is that I want this session to be as interactive as possible, because me just speaking here, this is not a lecture. I can't remember me going to lectures actually. We were also doing lectures online. We were just sitting there. So the lecturer was talking and we would say thank you at the end, and that would be it. So I don't want this to be that, because that would be a waste of your time and that would be a waste of my time. So what I want you to do is, please, if you have any questions, ask, right? So that's kind of what I wanted to say first of all, right? So I'll share the screen and start. We have plenty of time, I guess. So what is that? All right, so you guys can see the screen, right? Yeah. Can you see the screen? Can someone confirm?
Yes, sir.
Yeah. What you see is this CodeRally notebook, right? That's what you see. Because I have two monitors. Might be seeing something else. All right. So we'll start out. So when you guys reached to me, first I was a bit scared, to be honest, to approach this kind of topic, because it sounds really kind of like out of my league or something. So because I am not a CS student, but
Excuse me, sir.
the thing is, the
Excuse
thing
me,
is,
sir.
hello.
Wait, excuse me, sir. Sorry for interrupting. We all can see your desktop. So other than that, we are not
I just
having
can't
it.
see anything, right? Okay.
Only our desktop background with a blue color wallpaper. So that's it.
Okay. Can you see it now?
Okay, right.
All
Okay,
right.
now we can see. Yeah.
All right. It's just Linux being Linux. All right. So this is a bit of an advanced topic from the startup, because you should have some kind of understanding about what code is and how to code and what to do. So that's important. So I'll turn off my video. So just to go on. So we'll start with recursion. Before we start with recursion, what I want us to know about is to go through something called time complexity, which is really important in computing, right? When you write code, we have to maintain correct, when you maintain efficient time complexities. So I guess you might have gone through this already. I just wanted to recap for my sake as well. All right. So here's the thing, right? With we have this time complexity called constant time complexity, which is very simple, basic arithmetics, and like elements in an array are actually examples of O1. So this does not depend on the size of the input data. So O1 is pretty great, right? Then we have logarithmic time complexity, where the execution time grows logarithmically as the input size increases. So the difference between O log n and O1 is that the size of the input data is now an element that decides. See, because n is there, right? N is the number of elements. I mean, the length of the element. Anyway, so that means this logarithmically increases. So binary search, or like array sorting, and binary search trees, or made smaller programming things that you do initially are categorized as O log n. And then we have linear time complexity, which means when you increase the input size, the computation weight also kind of increases linearly, like a line, right? So that is iterating through elements of an array. So, if there are 500 elements, so it is O500, all right? So then we have linear arithmetic time complexity. Again, you can go through these things because I'll share this. So this entire workshop will be done on a notebook instead of slides. I just wanted to do that this way because transitioning between slides and code is a little bit inconvenient. So I'll be sharing this with you guys, so you can read this notebook and interact with the code yourself, change the values, and see how these things work. So that's what my target was. So I'll be sharing this. So n log n complexity is something really familiar to me personally because of this thing called fast Fourier transform, which is really important in electronics and telecommunication engineering. So fast Fourier transform, you might have heard about it. This is something where we change things, let's say a sound signal from time domain to frequency domain. You can Google and see what it is. So it n log n. Then we have quadratic time complexity. So this is like, this is unacceptable, to be honest, right? Unacceptable means this kind of time complexity for a simple problem is not efficient. That means you're not coding efficiently, and that means you're not scoring well in a competition, right? If your solution is O(n) squared, right? And it can be done in another way. So, so this here, it will exponentially increase, and bubble sort again can become this complex, and checking duplicates can become this complex. And also talking about machine learning, transformers, as the sequence token count increases, the complexity increases quadratically, right? So, and then we have cubic time, we have exponential time, and then we have factorial time complexity. And you can read through these things. What I wanted to generally observe, I mean, just to recap: constant and logarithmic time most efficient, and linear arithmetic time is generally considered efficient, but it is what it is, and it can, I mean, an application that runs a code that runs in linear or linear arithmetic time is generally scalable. and practical. Quadratic and cubic, these are less efficient, and exponential is the least efficient, right? These are usually avoided in programming, procedural programming, but when it comes to deep learning, we don't care about time complexity. Therefore, but am I missing the chat? No. All right. So that's that. Okay, let's start off now with recursion. What is recursion? You guys must have heard about recursion, and you guys must have implemented this in your code when you're doing your undergraduates. So I just wanted to know, like, what is the proportion of you guys? Are you guys freshers? Or are you guys like third year people, second year people? What's the composition here? Can somebody answer? Somebody from the organizing committee might be great. First and second years. All right. Don't call me sir, call me Amod. Okay. Please don't call me sir. All right. So first and second years. So you guys might have just started out. So recursion is the programming technique. Now, first and second year, I didn't intend this to be for only first and second years, but we'll see. We'll see as we go along. I'll explain as simply as possible. So what is recursion, right? So it's basically a type of programming, a method of programming, where a function simply calls itself inside the function, right? You have a function, you define a function, and then the function, all right, we implement this. Wow, nice, that's great. So you guys have courses, right? I kind of, yeah, those are like the same as assignments, right? So, okay, that's fine. That's really great that you have done this. So there are two key concepts we have to understand. The base case, or the case where the conditions will stop. Now, this is a loop, right? The function calls itself. So we want to, what happens is the function will keep calling itself iteratively until some kind of condition is met. That condition is the base case. This is where it stops. All right. The recursive case is the part of the function where the function calls itself or continuing to solve the problem. So two cases are there, recursive case and the base case. So these two are the key elements and the key parts of a recursive code. You have to be able to identify those two when you're coding, right? So how recursion works, we'll go to factorials. I hope all of you guys have some like exposure to mathematics, and factorial is this thing where we calculate, let's say, you guys know factorials, right? So for example, 3 factorial is 3 times 2 times 1. That's what it is, right? 3 times 2. So n factorial is n into n minus 1 into n minus 2 and ends in 1. All right. So this is something. Yeah. Yeah. So all right. So give me a moment. Continue. So this is kind of an implementation of factorial, right? These might be asked from you in a technical interview, right? So what I want you to explore and identify here is the base case. So we first define the base case. If n is equal to 0, then return 1. All right, so because if this becomes 0 here, everything goes to 0, right? So we want to stop this from 0, okay? So that's why we have this base case. And then we have this function where we just return n times the factorial, the same function of n minus 1. So let's say n is equals to, so if n is equal to, this doesn't work, this doesn't matter. So it goes here, 2 times n is equal to 1. And again, so you see the loop, right? You see the loop here, right? So when you run it, it's that simple. So we can add like really big numbers here as well. So yeah, Python probably cannot handle up to here, so you can see zeros. Anyway, so this kind of implementation, you can see that it can be a bit of inefficient because we are always doing the same thing again and again. The function is being called again and again. So that's not really great. So when n is equal to 0, the function returns 1. The function multiplies the current number by the factor of n minus 1. So continuing until it returns the base case. So until it returns the base case, that's what happens. So I just wanted to talk about this inefficiency thing. Repeated calculations. So for example, we are adding stack over stack. You know how a code works, right? In a processor, what happens is every process is a stack. You add a stack over one, every function call is a process, let's say, right? Then it adds a stack over and over and over again. So that would lead to stack overflows, which means that the code will not execute and it'll throw out an error, stack overflow, right? Because it would stop before that because of the kernels and stuff, but it would lead to a stack overflow. So that's bad, right? Memory. For example, let's say you have a computer with 2 gigabytes of memory. So you can't add anything more than 2 gigabytes into it, right? That's how RAM works. If some program is trying to write to a position in the memory where it is already been stored, you get a blue screen of death error because you need to fail, right? So that's, sometimes you might have experienced this with Windows. The blue screen of death is typically raised when this kind of thing happens. A memory address that already has a value is being written upon. Then the kernel itself will fail. The kernel's code is there to just fail the system and stop it from running. It's a safety measure because things have gone wrong, right? And the third thing is performance, right? So recursive solutions are slower. We don't want slow performing code. What we need is more efficient code, right? So this inefficiency here cannot be much enough illustrated because Python can easily handle this kind of thing. So you won't even see the I mean, it's almost instantaneous. You'll be wondering what the hell is this guy talking about. This is executing pretty fast. But the point here is even though this kind of thing, this is a simple implementation. Let's say this becomes a very complex implementation of a mathematical formula, especially something like we use in deep learning. Then what would happen is we would go out of memory very quickly, right? So just with my example experience on machine learning, out of memory errors are basically the main kind of errors that we get, which means that whatever the model we are training has run out of GPU RAM. So that in that case, it fails training, everything stops. Anyway, I just want to illustrate the inefficiency of recursion here. So the problem that you get is to find the nth Fibonacci number. You know what Fibonacci numbers are, right? I hope you guys know. I'll hope you can see the browser. Yeah. So Fibonacci numbers is this sequence of numbers where recursively the things are added. Right? So it starts from 0, it adds 1, and it adds the previous one to here, it adds the previous one to here, and it goes on like that. Right? So this is the Fibonacci sequence. So you might have seen this Fibonacci spiral as well. So our problem now is to find the nth Fibonacci number when n is given, right? So we can just simply get a sense of this by doing this, right? What is this? 0th Fibonacci number is 0. First Fibonacci, f of 1 is 1, right? So we can just write fn is equal to fn minus 1 plus fn minus 2, where n is greater than or equal to 2. All right, I hope you got this. So take some time to understand. So so I showed you the sequence. 0 is 0. The f1 is 1, and this goes on. When an number is given, this goes on, right? So this is kind of the recursive method of doing Fibonacci. Yes. So again, we have the definition. I'm doing this on Python because it's easy for you guys to understand. I guess, are you guys doing your coding in Python or any other language? Or if do you guys have any unfamiliarity with Python? Please let me know. But I can't do things basically because I don't know anything else, right? Other than C. Okay. All right, Python, that's great. So then you know what this is. It's simple, right? If n is less than or equal to 1, we return n, right? That's basically the condition, base case. And then this is the recursive part where Fibonacci of n minus 1 is same thing, right? Fibonacci of n minus 1 plus the same of n minus 2. So when n comes to 10, this 10 times, goes around, calls the function several times, and we can just print something. Let's print this. Yeah, you see the number of times the function has been called, right? So yeah, it's messy. So the function has been called a lot of times, right? I'm not going to count. Okay, so that is basically the problem, right? The function is being called again and again. What if this function is not a Fibonacci function? What if this function is something complex? What happens is it'll easily break down, right? The memory will leak, and it'll basically break down, right? So in a deployment, the pod will crash. Okay. This function, okay, so the problem is recalculates the Fibonacci number for the same input. So for example, let's say we calculate Fibonacci number of 8. Okay, so up to 8 Fibonacci number. So we're going on until the 8th, all right? So, and then now next time we are going to calculate the 10th Fibonacci number. The previous 8 times has been already done, but since we don't have anything to like get that data back from the previous execution, we're gonna do it again and again and again. The same thing up to 8 should be done again. All right. That's the problem. And you see the complexity here. The complexity is O to the power n, right? So this is like this is exponential complexity. If I enter big numbers here, this could crash here, right? To be honest, this actually could crash. Python would do something, I guess. It would save itself, but still, this is the problem with recursion. But recursion is great. Right? It's not something that's bad inherently. It is something that is inefficient, but it makes sense for some simple problems. But when the problems become complex, it will be completely infeasible. It would not be feasible to go to a recursive function. Right? We went through the addendum. I'm not going to go through the addendum again. So up to this point about recursion, I just wanted to know whether you guys have questions. So that so you guys have this thing, right? Or you can show a question on the chat. Again, guys can use this as well. Any questions about recursion? Guess not. We'll move on, right? Okay, so we just don't look at these steps. We're gonna go a bit advanced, but just bear with me. I mean, we'll go there gently. All right. So we'll start off with the first thing that is actually going to matter. Recursion doesn't matter much in actual program, right? Dynamic programming, right? So what dynamic programming is, it's kind of a technique that where we break down a larger problem into smaller problems. Okay, we have a larger problem to solve. We break down into smaller problems, and then we kind of solve those smaller problems. Okay, so there are 2 actual approaches here. We'll be talking about those. Solving each subproblem just once. and storing the results to future use. So here, whenever we do a calculation, we just store that somewhere in a persistent memory, right? At least for the session, right? So what we do is when we do a calculation, whatever calculation it is, we store it, right? We store the result. So DP is particularly used in optimizing problems where you need to find the best solution to multiple possible solutions. All right, so there are two key concepts: overlapping subproblems and optimal substructure. So you can Google these. I'm just going to give you a small intro into what these are. So dynamic programming is applicable when a problem can be broken down into subproblems. That is what overlapping subproblems is. That's the concept there, right? And then reused multiple times. So that means you divide the problem into subproblems, and then you have smaller problems now, right? Basically, what you have done is you have taken a large time complex task and broken it down to smaller, lower time complex tasks. Sorry, right? Lower, like the time complexity of those tasks are lower, right? So there are two approaches there. You should be like thinking, how the hell are we going to do this? So top down and bottom up. Top down is memory, bottom up is tabulation, right? Top down involves like solving the problem recursively, but storing the results each and every time, and they can be so that they can be reused. Okay, so there is a certain amount of recursion going on in the top down method. Yeah, because we'll illustrate this in an example. Just go with this. Okay, so the bottom up approach involves solving all the subproblems first, right? And then using these results to either add all together, multiply all together, whatever, right? To form the final solution. Okay. So the difference is memorization has some amount of recursion, but the recursion is with memory, right? This time. So that part, like where the in that Fibonacci case, the 8 Fibonacci number is being calculated. That means 1 to 8, we have all those Fibonacci numbers. They have been stored, right? What we need to do to compute the 10th, we need only the 9th and the 10th. That's it. The others we have, right? So that's memorization. So bottom up is something different. We completely like what do you call it? Demolish the question problem into smaller problems, and then solve those smaller problems, and then get them all together back again to form an answer. All right. So the DP solution using memorization for Fibonacci, right? So now this code and this code is quite similar, right? There's only a very small change. We have the memo, which is a dictionary in this case, right? So what happens is when n comes here, if n is in memory, right, return so this nth element of the memo dictionary. If that is the first condition, but we're not going to go to any calculation. We're just first checking whether n is there in the list, in the memory. Now, if it is there, fortunately, if it is there, then no, there is actually nothing to do. The complexity becomes O1. right? It's why is it a one? It's just an element of a diction, right? So, or a list. So if n is less than or equal, then the same thing, right? Then we are going to the next step, which is this is the base case condition for the recursion part. And then we do this, the same thing here, right? The same thing here, but see what we are doing. We are just storing this result, right? In this dictionary, to be honest, right? So let's run this thing. Of course, it's gonna be 55. So and all right, so and print it like this. So I just wanted to make sure that that's okay. So that kind of syntax you might be a bit unfamiliar, but this is called f strings in Python, where we can like call a function within a string statement. So, I just want to write that. So that's it. So this way we have created basically memorization based Fibonacci algorithm. All right, it's a Saturday night, so bear with, okay. All right. Okay, so the explanation here is we use a dictionary memo to store the results of the previously computed Fibonacci numbers, avoiding redundant calculations. So for example, if n is equal to 10, checks if f10 is in the memo. If not, it calculates it using the recursive relation. It avoids calculating values like f9 and f8, which are used multiple times. That's very simple, right? So I hope you got an idea just into what memorizations in dynamic programming, right? So this is kind of a top-down approach and has a recursive part in it. All right. Okay, next. Next, we're going to go do Fibonacci with tabulation. This is going to be a little bit boring because how can I make this more engaging? This is just coding, to be honest with you. I could, so we'll see, okay? We'll go on to some interesting stuff in ML later on that uses 3D algorithms. So ML, we tend to use 3D algorithms. We're going there, we're getting there, but just wait, okay, basically. So here, this sounds a bit complicated, right? So what we're doing is we fill up this DP array. There is this array, right? So if n is like 5, for example, we start with DP2 and end up with DP5, right? So, and then for I range 2 and n plus 1, we do, this is basically a list operation that we do here. So in intermediate results of each of and every step is being stored in this DP list. You can go through this at home. I just think that will be boring for me to go through this. So this is same thing, 55. So yeah, this there's a small example. For n is equal to 10, we fill up the DP array starting from DP2 until DP10. The final result is found in DP10. This is like, you know, we fill out the things, we fill out this list and get the answer. Now the example for BP I wanted to discuss with you. There are two examples. No, there is only one example. Is Levenshtein's distance. What the hell is Levenshtein's? Have you heard about Levenshtein's distance? If you guys have gone into competitive programming competitions, you might have heard about Levenshtein distance. Anybody here knows about Levenshtein distance? You can just I can't keep checking two places. You can call it. We can use it for more deep problems breakdown. I might not get what you're saying, but if there is, if anybody has heard about Levenshtein distance, nobody. Okay, now Levenshtein distance is this, right? You get two strings. Okay, you can only do certain operations: insertion, deletion, and substitution. You can substitute a character, you can insert a character, or you can delete a character. Right? These are the only operations that you can do. What you need to do in the Levenshtein distance problem is to find the minimum amount of operations needed to get from one string to another string. For example, word 1 is given, word 2 is given. We need to find the minimum number of operations needed to convert the first word into the second word. Okay, so I just wrote a small code here. I wanted to add comments as well. I'm not gonna go with this because you can at home, you can go through the code, and I have done my best to explain this, right? Because me explaining this in this session would be boring. So here, so I've done my best here, all right, to explain what happens in this function. Okay, so Levenshtein distance, it's kitten and sitting. So go to it. Yeah, it's true. So Levenshtein distance is that, all right? All right. So why even learn these things? The Levenshtein distance. This problem might come up actually in things like we have this IEEE, right? You've got the, I can't remember the name. So basically, I have an experience with this. What the hell was that called? Triple Can anybody point it out? I can't remember the name. So IEEE expert. All right, I think it's coming up. Yeah. It should be coming. So what basically happened was we got, I mean, it was our first time going into this thing. We were engineering students. We didn't know much about code. We didn't know Python at all at that time. At what we only knew was C and C++, because those two are the languages that are being taught because of IoT purposes. Right? For IoT, we use C, and so what I actually tried to do is we tried to solve these string problems with C. I was like, it was like people were like solving some problems within 2 minutes, and we were like struggling for hours, right, to solve the same problem in C. So, but because Python is there, you guys, it's better if you can use Python in competitive programming, because it doesn't make sense to like we only knew C because that's what we had to go through. But however, we finally did at least, I think, 3 questions, 3 problems. That was the first experience of IEEE Extreme for me. And it's coming up. I hope your student branches are aware of this, and please participate, right? Because you are computer science students. I have done my best to explain this. So I'm gonna go with applications of these kind of dynamic programming methods. So this Levenstein distance, for example, I took this out because this is a certain problem, right? This is like what do you call bare bones problem that you get most of the time. Levenstein distance is used in NLP. So because I specialize in LLMs and natural language processing, so that's my specialty. Therefore, I do have some experiences with these. So Levenstein distance, and there's something called Rauch score, which is really important these days. I'll tell you why. So Levenstein distance is basically, we are trying to find out the difference between 2 words, right? So it's like, it's not contextual, but it's like whether they are close enough. So for example, for spell check, we use it, right? So when you're using your keyboard spell check thing, this is Levenstein distance is what is being done. Text similarity. The distance can we measure the similarity between 2 pieces of text, right? But this is not contextual similarity. This was, I mean, Levenstein distance is something that is not done anymore, kind of, to find the difference between two strings. The reason is we have these things called vector databases and embedding models. We can get a contextual idea, but this doesn't give us a contextual idea, but it just gives us whether these are identical. This is really important for you guys, because this is a part of the algorithm that is used by plagiarism detection algorithms, right? So basically, Turnitin uses this to. So there are certain layers in Turnitin now that calculates the similarity between 2 texts. I mean, your assignment and whatever that is on the internet. And then they also do OpenAI calls and get the prompt, I mean, get the result, and then they compare that there. So there's a huge thing going on now at Turnitin. So anyway, so this is still being used in plagiarism because the same words, like if the same words are being used, that means you have plagiarized, right? So that's something that's there. Then there is this thing. And now I'm coming to Rauch scores. This is also something that is done through dynamic programming. Rauch scores is something called recall-oriented understanding for gisting evaluation. This is actually a measure of the difference between two sentences. That was two strings. I mean, this approach is a little bit different. So there are several types of Rauch. Rauch 1 is unigrams. So what we do is we compare the first word of the first sentence with the first word of the second sentence, like that, right? And then we get a score, okay, out of the number of words. So there are 1, 2, 3, 4, 5, 6. All 6 are matching. That means 6 over 6, that's 1%, that's 100% overlap. Now you must see a pattern where these kind of things can be used, are used in plagiarism detection, right? Rauch score, okay? You can write an algorithm yourselves just to like find out the Rauch score between two paragraphs. Okay, so try to do that. So that means, I mean, if the value is lower, that means there is less overlap. That means the sentences are a bit different, right? We have Rauch, the Rauch scores have kind of 3 measurements. This is Rauch n, which is so Rauch 2 means the first 2 by 2 we are comparing, right? And we have Rauch 3 and whatnot. Okay, then we have Rauch L. Rauch L measures the longest common subsequence between the generated and references summaries. So the quick brown fox jumps over the lazy dog, and then you have fast brown fox leaps over a lazy dog, right? So the longest common sequence is this is not similar, brown, fox, this is also not similar, right? Lazy and dog, or the lazy dog. So this is the LCS length is 6, and there are 9 words here, 9 over 6, so we get a number. This is the Rauch L number, and this is kind of the F1 score in strings, right? So you can actually write some code on this at home, because I just added like examples, so you can like try to create your own code and see whether this works. Okay, then next one is Rauch S. These are called skip bigrams. Skip bigrams are with pairs of words that have in the same order, but both the generator and reference, but may not have the same words in between them, right? This allows for more flexible matching compared to strict bigrams. So this is again, these Rauch scores are really important in plagiarism detection. Okay, I'm not telling you how to cheat. I'm telling you how to create better plagiarism detection software. All right. So you can actually create an algorithm as a project, a side project, because you get to work on this. You get to learn coding skills and dynamic programming. This is a bit complex, but this is the Levenshtein distance itself is complex. That's why I didn't go on to explain the code, and I just did my best to explain it here. Rauch will need a lot of code that you need. Here's the thing, in Python, there you can actually get the Rauch score by just importing a library, but that's not what I want you guys to do. You guys try to create at least Rauch 1, okay? And I'll create an algorithm in whatever the language it is, Java, or Python, or anything. Just try to make this for yourselves. And instead of uploading, I don't know, you guys might be doing certain websites for plagiarism. Instead of that, you can use this intelligent thing that you have built and somewhat get a more confident answer of how similar your answer is to others. How much have you plagiarized? So these are string related stuff. Okay, these are all text. That's why I'm an NLP engineer, so basically that's why I'm always pushing this text thing over and over. It might be a bit boring, but it is what it is. How Rauch relates to dynamic programming. So Rauch L metric, which is the longest common subsequence. So initially we initialized here. What I did this was something that I just told ChatGPT to create a sample explanation of this. So I don't know about the accuracy of this one, but I just didn't want you guys to quote this here. Just wanted to let you know that participating in competitive programming makes you think and makes you learn kind of these kind of techniques of programming that has actual uses. These are not just, I mean, you might be thinking, hey, lead code stuff, what the hell? What am I going to do with this? There are actual applications of these kind of competitive programming questions available. So available means that you can build, right? So that section is also done. Okay. Do you have any questions? Let's go. Okay. Chat. Okay, guys are feeling boring and leaving, I guess. Anyway. Give me a moment, please. Okay, so sorry about that. We'll go to string algorithms, right? So introduction into strings. So I'm gonna go ahead and give you guys just an introduction to what strings are. So for the best place to go and find out what a string is actually Python's documentation, right? You guys can see the screen, right? Hopefully, okay. You can see the browser, right? Can someone confirm? Yeah. Here's the thing, right? If you guys can, I don't know whether that has been disabled, but if you can it's okay if you can like unmute yourself and ask questions, because that would be really great. I'm feeling a bit sleepy as well. So having a conversation would be great. Right. This is string. Okay. What is a string? Strings are immutable sequence of Unicode bits. String literals are written in variety of ways. So this is how strings can be written in Python. What I want you to know is that there are immutable sequences of Unicode code. What the hell is Unicode code? Unicode is this. It's a kind of a mapping between numbers and characters. Basically, that's what it is. Okay. There are certain, so for example, like ASCII, in ASCII, we only had English, right? Now we have this amount of characters, so 149,878 characters with code points, covering 161 languages. So each and every letter on any language of the world in these 161 languages has a unique number that represents it, right? Character by character. So in Python, strings are immutable. These might be asked in interview questions. A sequence of a Unicode code. All right. So coming back, introduction to string algorithms. String algorithms are fundamental part of computer science and yes, because we are now dealing with a lot of LLMs, right? Basically, a project that we are engaging on at the moment is where we get a response from an LLM and we map it to something else. Let's say YAML, right? So what the LLM gives a certain response in a certain structure. We need to extract certain information from that text and populate a YAML file or a JSON file. All right, this is really hard because the LLM can give certain different kind of patterns and different kind of responses. This is something that is being done right now in the industry, right? So therefore, string algorithms are not just some things that you learn for competitive programming. These are real things that you will be implementing when you go to the industry. All right. So doing this again, I'm just selling you IEEE Extreme and other coding competitions. Just participate first. I have not participated in physical ones because we had COVID when we were studying. I mean, we were undergraduates, but now you guys can go there and like feel the audience and talk to brilliant people, talk to your peers, just participate in groups, think in groups. This is what, so these kind of things are really important. Now, if someone comes up to our company and says, hey, I have a better method to map these strings to JSON, we will hire you with whatever the money that you are, whatever the amount that you guys are asking from us. That's the kind of thing, right? Because we have some business value on your skills. If you can think and come up with creative ideas to do things, that is what we are looking for, we as in the industry, right? So whenever we have an interview, what we look for is people who are creative, not people who will do what they are told to do. We don't need that kind of people. What we need is people who can think creatively, right? So to think creatively, you have to challenge your brain. So challenge your brain, just get into as much coding competitions as possible. All right, that way, I mean, you don't need to win these things. You just need to participate and think. You don't need to even solve the problem at the time given. You can take the problem home and think about it and come up with a unique solution. Right? There are tools available now. Python is really, really great with strings, with handling strings. So there are a lot of packages, there are a lot of frameworks that helps you. So please do these kind of things. Be proactive in your learning experiences. Just don't do this week's assignment and then just sleep. Just that is the extra work that you have to put in to get into the industry once you are graduating, because the competition is that high. To be honest, it's really, really bad out there currently. So you have to be really skilled to get into the industry. After you get into the industry, it's smooth sailing a little bit, but getting in is a bit hard. So that's why I am iteratively saying that just try these things yourselves. Don't wait till somebody else is explaining these things to you. That doesn't work. You have to think, and you have to like challenge yourself to know what, to understand what this problem is. That is a way of creative thinking. Okay. So strings. So this guy, I just said text processing means this LLM text processing. Search engines obviously use these kind of string algorithms because web crawlers have them in Google. Bioinformatics. What is bioinformatics? Using AI to find patterns in genomic strings. So genes can be represented as binary values. We can find out certain patterns in genomes. So that is something by and data compression. And why data compression? Because we need to find, so for example, lossless compression means you get a file and you find the patterns, and then you represent that pattern in one variable. You go around like that, and the file size gets lower and lower. We'll be looking into one such kind of compression method later on. Just wanted to tell you how important this is. This is kind of more like recursion and kind of this dynamic programming is okay. It's really important, but string algorithms and dealing with strings is kind of something that is really important for you. So for you as people who are entering into the industry. So what are the key concepts? We have pattern matching, finding occurrences of a pattern on a string, right? That is something you can do. String manipulation, so modifying and analyzing strings. You can get a copy out of a string and then manipulate it in some way and create a new one. We can extract substrings out of strings, can search, so can concatenate, we can replace, so those kind of things. This is called string manipulation. Suffix arrays and trees, so data structures used for efficient string searching and manipulation. This is kind of new. This is kind of not new, but it's a little bit more complex. Think about it like this, right? You have a lot of amount of strings, and you need to find out relationships between those kind of strings. You can actually get those strings out onto a tree, and those are called tree structures. And then traverse and find. You can just Google these things. Okay, so then finally regular expressions. When it comes to extracting text from LLMs and training LLMs itself, we use regular expressions. You might have heard about tokenizers in large language models. So, for example, OpenAI has their own tokenizer. These tokenizers are made out of regular expressions. All right, the actual like dividing a certain sentence into tokens is done by regular expressions most of the time. Now there are more intelligent methods, but in GPT-2, for example, GPT-2 is the last open source project that GPT did, OpenAI did, and the tokenizer was just a string of projects. That's it, right? Projects match. Okay. All right, so we have problems now. The problems is all right. So the problem number 1 is given text T and pattern P, find all the occurrences of P in T. These are some kind of basic problems that you will face in competitive programming. So this is naive. The first is naive approach. Naive, what does that mean? Naive means we're not using too deep kind of algorithms. We're just naively doing a search, right? So the naive approach is, you can see the thing here, the function. So basically we take two strings, we get the lengths of them, and we initiate a list called results. So basically what we do is, the algorithm actually checks if the pattern P matches with the substring. We divide the P thing, the P string, into substrings, right? Okay, so n minus m plus 1, right? So we divide it and we see whether the pattern P is in them, and we slowly append the results if there is. If there is not, we won't. So for example, this thing, pattern found indicates 0, 7. So this is the result. What we are going through is we are creating a substring out of this, like 1 by 1 or 2 by 2 like this, and checking whether P is there. All right, this is the simplest possible way of finding a pattern in a string. However, when the string is very long, this is not going to work. This is not going, I mean, it's going to work, but this is going to take a lot of time, right? So that's why this is naive way of doing this. Then we have KMP algorithm, Knuth-Morais-Pratt algorithm. So this is left to the reader. You guys can go through this again. I forgot to put it. Anyway, basically this is an improvement of the naive approach. These kind of things might not be really important in competitive programming, but just as an addendum, we could guys could work on it, right? Then suffix arrays efficiently find and process all suffixes in a given string. So a suffix array is a sorted array of suffixes given in a string. It is often used in string matching and other string processing tasks. So the suffix array is constructed by generating all possible suffixes of the string and sorting them, right? The suffix arrays are useful for in various applications. This part of the code can be actually part of the code can be optimized. We can use Pydantic to optimize this part of the code. I hope you understand list comprehensions, but list comprehension, list comprehensions are great and all, but try to, like, you get this, right? You get this notebook. Try to find a more efficient way or more Pythonic way of doing this. So right? Okay, so the keyword is pydantic. Pydantic has something. It's kind of new. It's there in 3.12. So I'm using the latest version of Python. Use the latest version. Sorry about that. If there is any sound. Okay. So the application is suffix arrays are usually various array, including pattern matching again. Same thing. Now we are coming into regex. This is the most important thing that I want to discuss. I want to discuss what is regex. Have you heard about regex? Have you used regex ever in some kind of capacity? Anybody here has used it? No? Okay, so it seems that you guys haven't. So regex is something called regular expressions. Okay, regular expressions is kind of a scripting language that we use for finding patterns in strings. This is really important, as I told you before. Tokenizers in LLMs, you might have heard about tokenizers, to like break down sentences into tokens, they use regex. So I have this small, I want to share this small website with you guys. So basically, all right, it's a direct message to somebody. I'm sorry. Again, hope everybody can see this link and go there and actually get a sense of what regex is. But since ChatGPT is there right now, I mean, before ChatGPT was there, right? These things were required by, I mean, certain kind of programmers needed to know what regex is, like regex language is. Now it seems like gibberish, right? It is like, it is, see, these are like, right? So this has another 1,001 years. So see, there are certain, so there is PHP, there are a lot of implementations of regex, and it's all the same. It's similar way. So just go through these kind of regex websites and just go through them. I'm not gonna, let's say this is a certain type of way to efficiently find patterns in strings. All right, that's all, right? So Python has its own regex I mean element, right? You can just take a code and type import RE, and so this is here, this is basically built within Python, right? However, since you are starting out with regex, I want you guys to just ditch that regex within Python and actually use a package called regex. All right. So for that, you need to do a small pip install of regex. This is usually very straightforward. You can go to the terminal and type in pip install, right? So I already have installed it. Mine is already there. So just you have to, like, before running any of these code, when you get it, because it won't work, right? Because your system might not have it. This is a package. So this package is much more powerful than what is built in Python, right? That's why I'm just telling you guys to start off with this without going with the built-in module, right? So it supports advanced features like full Unicode support. That means full Unicode support means you can use regex for other languages as well, not only English. In the RE package, you can't do that. Fuzzy matching, so tolerates small differences between pattern and string. So this is like, okay, it's not exactly matching, but there is a certain amount of matching going on. So I'm going to return it, something like that. And enhanced regex syntax. So there are nested sets and recursive patterns. These things you can go through with whenever you encounter regex script. It's better to go with ChatGPT, because ChatGPT has the GPT models from starting from GPT-2 has been trained extensively on decoding regex, right? This is something that you can do with any kind of base model. The free versions can also do it. Paid versions can also do it. The APIs can also do it. So just you don't need, what I mean is that you don't need to memorize these things, but let's go through some of them, right? So basic matching, right? So what we are going to find is matching words with accents, right? Cafe Müller is a famous cafe in Germany, right? So what we do is this R double quotes. This B means this is the word boundary, ensuring cafe is matched as a whole word, right? So, and then this is the pattern, and again we need to have a word boundary, right? So this /B is actually the word boundary, all right? And then this is R string, and then case insensitive and Unicode aware matching. So RE search flags ignore case. So RE.ignore case means now we are searching for C capital cafe and C simple cafe, but the cafe here is in a capital. So that's where we just say ignore case. Okay, so if a match is found, it will say, yeah, here's the match. If it is not, it will say no. This is a simple function. So again, I have explained each and every use of the, each and every definition of the regex function here. This is a simple one. This thing you can just remember yourselves, right? Okay, so the match is found. Okay, so just there is no match found, right? So CAF is not anywhere here, right? We want the pattern and the text. Like this is, I told you, like we went through this naive method, right? This is a more powerful method of going through text, all right? Then fuzzy matching. Again, fuzzy means there can be small differences between the similar texts. We allow that. Okay, we can allow that. So again, import regex as RE. You can say import RE. Okay, but since we are using the regex package instead of the module in Python, we are doing it like this. Fuzzy matching to allow one insertion, deletion, or substitution. Right? That means this match can have either one insertion, one deletion, or one substitution. Okay. So one letter might be missing, one letter might have been substituted, or one letter might have been inserted. Even that case, we will return it as a match. Okay, so here, this is the pattern. Again, it's an R string. You can like find out what these are. Lazy. So we are going to find the word lazy in this text. As you can see, lazy is with L-A-Z-I. So that's the problem here. So we are saying E is less than or equal to 1. That means matches found lazy, allowing the edit number. So the edit number should be less than or equal to 1. If it is so, then again, it will find it as a match. Okay, there you go. And if we turn this to Q, now will this work? No, because there are two changes, right? Or so let's try this out. Let's try the other things. Let's say I is not there. Match is found. Why? Because there is only one deletion, one edit. That's fine then. Okay, so we can actually change the value here and do get our intended result. So I have added a Y. Will it work? Yes. Right? It found. Yeah, it found a match. Just because there was an insertion, it didn't count. Okay. All right. Right. Then we got named capture groups. This is advanced. This is you just can use ChatGPT. But I mean, coming up with this something like this on your own is quite nice to have, right? It's nice to have. It's not recommended. It's not required, right? But in computer programming, you can use this. I mean, if they allow you to use the regex package, I don't know whether that is possible. If not, go through just the RE module. RE module has most of these things in like in production. Also, we kind of don't use the regex module much. Regex package much, but only the regex module built within Python, because it's basically enough. But still, this you can do a lot of interesting stuff. Right? I want you to do interesting stuff, so that's why I just introduced regex package. Right? Any kind of Python over 3.9 has RE built into it. Okay. So extracting the date components using named capture groups. Named capture groups are, we are using kind of a method, some kind of a method to extract a date. This is really something that we are doing currently in one of our production projects that are in production, right? We get an LLM response and we have to map it correctly to the month, date, and whatever, right? So these are real things, like these are real implementations. So here we start with digits 4. So D/D is number of digits. It captures this. There's a P here. You can go through that cheat sheet and just find out what these things mean. So we get year as the in a 4-digit method, and then matches the hyphen separator between the year and month. So here you have the hyphen, right? So because we expect it to be a hyphen, so that's fine. And then we get the month. We get the month as 2 digits, and we get the date as again two digits. So right. Then we this is again an R string. R strings, you have to know what R strings are in Python. Again, re.search pattern and text. That's it. So pattern is this, text is this. Then we're just extracting, and we are using F strings again just to match these things. Okay, so we get a nice output like this. So, right, all right. So it's the event is scheduled on 24. So it's today, right? Okay. The recursive patterns. This is a sentence with nested parentheses inside it. Again, we are finding recursive patterns in this case. Matches an opening parenthesis. Okay. And this is the non-capturing group, which means that we are discarding these kind of things, right? Matches any sequence of characters that are not parentheses. Again, this is a bit advanced, but what you can just ask ChatGPT to do this, right? I want this out of this, and I want to extract parentheses. So see, nested parenthesis is being returned here. Okay, so all right. Oh, then you can use these regex lookup websites. To be honest, I included some links within. So here you can just Python's regex flavor. So regex has certain flavors. There's a Rust flavor, Golang, Java 8, and there's a guide as well. You can insert your regex expression and insert the string, and you can get the explanation actually also about your regex expression. So I have included those. There are two actually. Right. This is a recipe sheet here as well. So you won't be able to use ChatGPT in competitive programming. I don't think so. So just remember some of these things. Okay. So those resources are also given. Now we're coming into greedy algorithms. So this is the final part. Hope you guys are still there. Okay, half of people have left, but that is expected, right? It's a Saturday night after all. Okay, introduction into greedy algorithms. What are greedy algorithms? Greedy algorithms are a class of algorithms that make series of choices, each of which looks at the best moment with hope that these local optimal choices will lead to a global optimal solution. What does that mean? Greedy algorithms are generally used in optimization problems. Okay, so if we have something to optimize, for example, if we need to compress a certain text into much more, efficient format, we can use a greedy algorithm, right? So what this does is like it makes choices locally, expecting that the local choices that it makes will converge down into a global optimal solution. All right. When that is exactly what greedy algorithms are. Greedy algorithms are applicable when problem exhibits greedy choice property and optimal substructure. I'll explain what these things are. These properties ensure that making locally optimal choices leads to globally optimal solution. Local optimals, right? So for example, it's like this, okay? So if communities, we have communities, right? Schemes, let's say, of houses, right? Gets together and works for a certain task, expecting that all the other schemes around the area will do the same. that is a greedy algorithm. Right? That is the use of a greedy algorithm. So something like dengue cleanup, right? These days, it's there. So a community of people get together around a certain area and does that thing. Then the other community there, they do the same. So like that, something like that. All right. So this is optimization. Okay, basically. So greedy choice property, the property that states that a locally optimal choice at each step will lead to a global optimal solution, right? So local optimal, any local optimal will lead to a global optimal. Global means whole thing. Local means we are subdivided into certain parts. Then the property is that any local optima will lead to a global optima. Example, in the activity selection problem, choosing the next activity that finishes the earliest ensures the most activities can be selected. So activity selection problem. I removed. Again, Custer's minimum spanning tree algorithm, also I just removed it because it's too much for you guys. Then optimal substructure is that the problem exhibits optimal substructure if an optimal solution to the problem contains an optimal solutions in the subproblems. This is basically two types of things. Like we say that any local optimal leads to a global optimal, and we say that the other way around, any like a global optimal will always have smaller suboptimal paths in it. Okay, see, this is a bit advanced. I hope second years and first years might not be much of I mean, you guys need to learn a little bit more maths for this, but statistics or something. But greedy algorithms basically are those kind of things. You can can find explanations, easy explanations online about these kind of algorithms. These can actually be used in advanced, very advanced competitive programming problems, leading with optimization. Right? These are majorly optimization problems. So for example, Huffman coding, you might have heard this. If you have, Huffman coding is again a compression algorithm. It is used actually in telecommunication as of now. Also, Huffman coding is used. So Huffman coding, again, it's a greedy algorithm that used in data compression. It assigns variable length codes into input characters, again, with shorter codes assigned to more frequent characters. Okay, minimizing the overall length of the encoded message. Simple. I think you got it, right? It assigns variable length codes to input characters. Shorter codes are assigned to more frequent ones. Longer ones are assigned to less frequent ones. Let's say we have a string, we are going to send a message to a person, ABC. That is our message, ABC. All right. What we do is we encode in ASCII, and what we have is 8 bits. So for each, that means 8 times 24 bits. We're sending 24 bits. What if we are sending something like a something like as a iterative property? We can that means that the value the ASCII value corresponding to A is being sent 3 times, right? Instead, we can represent A in let's say 4-bit character, right? 4-bit representation, bits binary this, right? So what happens here is then we expect that by doing that, the length of the code is being, length of the bits that we send is being reduced or optimized. So again, what we are doing is we are doing a local optimization, hoping that in doing so, it will lead to a better optimal solution. All right. So this is exactly what this code does. Again, I'm not going to explain this code. You can just try to do this. But for the Huffman coding thing, I just came up with a better example for this. Huffman coding, again, an efficient method of data compression and data assigning variable length codes into characters based on their frequencies. The idea is to use shorter codes for more frequent characters and longer codes for less frequent ones, right? Thereby minimizing the overall length of the encoded data. This is just compression, right? So we have a small kind of a mathematical explanation. See, we have a set of characters, C1, Cn, C1 to Cn, with corresponding frequencies. So we assign frequencies, number of times, okay, that thing appears. Huffman coding builds a binary tree where each leaf node represents a character Ci and its frequency Fi. So it's like a bracket with, let's say it's C1 is A, how many times A was there, the frequency, right? Internal nodes represent some of the frequencies of the child, right? Here's this how the algorithm works. So we create a priority queue. This is called a minimum heap that initially contains all characters with its frequency. What is this? I'll show you what this is, right? We will do something called byte pair encoding. So you can illustrate it much much better. It's this Huffman coding is a bit, I don't know, it might be a bit advanced. And I have learned this a bit earlier. So for me, the intuition behind this is a bit forgotten. So, but byte pair encoding, I'll explain. Create a priority queue or min heap that initially contains, okay. That means we have all the characters, we have all the frequencies of those characters. How many times each one of those things are there. Then tree construction, where there is more than one node in the queue, remove two nodes, okay, with the smallest frequencies. Create a new internal node with these two nodes as children, and the frequency equal to the sum of the two nodes' frequencies. Okay. Then insert that new node back into the priority queue. Do this iteratively. Okay. All right. So traverse the tree from root to the leaves, assign 0 for each left branch and 1 for each. So the path from the root to leaf node gives the Huffman code for that character. So these are vector mathematics. So this is a simple explanation. Consider this. Okay. So you have this thing where there is a string with the frequency of A is 5. So A is appearing 5 times, B is 9 times, C is 12 times, D 13, E is 16, and F 45. Now we first create the minimum heap here, right? It's just, I told you, it's like a bracket and it's like a dictionary, all right? So then we build the Huffman tree, okay? We repeatedly extract two nodes with the lowest frequency. So what are the lowest frequency? A and B, right? So we get AB, right? And add their frequencies together to get 40, okay? And then we add, now this is our new node. Then what is the lowest two frequencies? Okay, we have 12 and 13, right? Again, we combine CD. Now we have AB 14, CD 25, because the addition is 25, E16, F45. Again, now we have these two are the minimum ones, right? Right. Then we add ABE, right? It's 30. Okay. Wait. All right. E16 and AB14 create a new frequency is 30. This should not be ABs. I'll correct that. When I upload, I'll correct that. Sorry about that. Okay. So basically what we do is we get a final Huffman chord of 100 and that's it. We said that. But the thing is, we have to have the same kind of strategy to decode it, right? So now, that is, so now we assign binary codes, each character by traversing the tree, starting from the root 0 to the left of the edges 1. So for example, F45 assigned 0, A, B, C, E, D, E 55. So split to CD 25. Again, we assign certain numbers. We can go through this. And then this is the bit. This is like telecommunication kind of thing. So the number of bits have been reduced. Huffman codes are generated to minimize the total length of the encoded data given the character frequency. For example, more frequent character F is assigned to the shorter code 0, while less frequent character A and B are assigned to longer codes. So most frequent ones get 0, see? Because then there will be 45 zeros. That's fine. What if this had like 7? There will be a problem, right? Then this is okay. So that's Huffman coding. These are greedy algorithms. Now we are coming into tokenization. This part of the workshop is actually heavily inspired by Andre Karpathy. You might have know him. He's one of the major people who were there at OpenAI when they built GPT-2. Then he left OpenAI and now he's basically a teacher now. Like he teaches the basics of large language models. So I'm coming into tokenization because it's familiar to me. All right. Okay. Tokenization is the heart of much weirdness of LLMs. So sometimes LLMs can't spell. Right? The reason is tokenization. Why can't LLMs do super simple string processing tasks like reversing a string? That is also tokenization. You can try this out actually, right? You can try this. You can give a string and say, hey, reverse this. See whether the large language model reverses, right? Experiment it multiple times and see, okay? Why is LLM worse at non-English languages? For example, when we ask a Sinhalese question, we get a Sinhalese answer, but the problem is we can't decode it, right? It's not optimal, at least. We can get the basic idea, but it's not optimal because we don't have a tokenizer sync. And if anyone here likes to pursue machine learning, with open hands, I invite you guys to explore on creating a tokenizer for Singular as your final year projects. I don't know whether you guys do it in groups or not, but this should be a group project. That would be amazing. Like you would serve, like you'd be hired by any company as an AI engineer or senior AI engineer. Anyway, I mean, not right out, but you will be hired as an AI engineer, obviously, with a good pay, because we don't have a Sinhalese tokenizer. People started out trying different ways to create tokenizers, but yeah, it hasn't been done yet. So LLM based at simple arithmetic. So some basic arithmetic tasks, LLMs can't do. There is tokenization. So again, go through with these things. What I want to talk about is not what tokenization is. So for example, this string. So how these things are tokenized. For example, when we create Python code, we have, I can show you here, each of these space is a token. Okay, each of the space is a token in GPT-2, by the way, not in GPT-4. They have added spaces now because we need spaces for Python code, right? When GPT generates Python code, it needs to have spaces. So instead of adding one space at a time, what if we add 4 spaces altogether? Because the indentation is 4 spaces, right? So you know it, right? Indentation in Python is just 4 spaces. So what if we have a token for 4 spaces? We can add that one, right? So basically, this is kind of an activity that we're going to do. There's a function called OR in Python, which like returns the Unicode code point of a character. This is like a mapping of a word, a character, and a number, right? So, for example, to process natural language, to process strings, what we need to do is to convert strings into something numeric. Because LLMs work, our machines work, or what do you call computers work with numbers, not with language, right? So we need to have a method to do that. So one of the methods is actually Unicode. So Unicode works like this. So what we get is the Unicode code point. So for example, you can just call this function ORDA, and it's 97. So we could add anything, an emoji or something. Right? Get an out, right? But you can't. See, you get a number. That means you have for each and every character in any language, there is a number sign. You can find out what it is with this, but you can't just enter string here because the word function does only accept characters. So I just have this. Okay. So let's see what the numbers are in Python, right? So here are the ones. So as you can see, this is very early here. So the exclamation point is 33. That means it's a basic, right? So then 3, 4, 6, 2, 3, 5, C. These are the numbers of R, U, O, R, right? Is it the same? Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. That's 9 actually. That's the actual problem with single, because we like to count these as characters, right? So I is one character and Bo is one character, all right? But that is not how Unicode works. So, right, certain of these ones are also they also have a certain Unicode value. So this is one of the major problems, that we cannot easily create a tokenizer for singular. Anyway, all right. So it's the same. We can like hello world, we can get the numbers like this. So for each and every letter here, okay, so list for each and every letter, we get values. Here 32 is the number for the space, right? That you can play around with this. And I found out some text here from a website. So these have this, so Unicode allows certain emojis and kind of these things. the emojis that you guys are used to are all supported by Unicode and UTF-8. So what I wanted to do is just find the length of these. So there are 533 characters here, and these are the numbers. So I just listed the map like the values to some kind of integer. Okay, 0 to 55. Okay, this is just the encoding, and then you can find the encoding length is 660. That means again, it's some same thing that we saw with Sinhalese. IBO and VC only this amount of characters, but actually it's different. So there is a significant difference between the encoded value and the actual number of text. I'm not checking questions. Yes, using regex improve the performance of the code? Yes. Like using a regex search an item using string rather than using a traditional. Yes, regex does indeed make things more efficient, and you can do a lot of things with regex. So don't need to like write us like there are flavors of regex. I told you before. For like each and every language there are, but Java I'm not sure about Java. They said they had some version for Java 8, but I don't know. All right, so this is something. This is just wanted to illustrate this, right? So what we can do here is basically we need to optimize this. All right. So if we are sending this text to an LLM, okay, to an LLM, all right. So transformer complexity is O(n) squared, right? Okay, so when we are sending, see this O2 to the power n, sorry, right? It's exponential. It becomes exponentially higher. That means we have to concatenate, we have to find patterns in strings. Okay, so for those kind of things, we need greedy algorithms. So one of those greedy algorithms is called byte pair encoding. Now we went through one, Huffman coding. Now this is byte pair encoding. So just I wrote a function to calculate the frequency of the consecutive integer pairs in a given list. What does that mean? That means we get IDs of the tokens. So tokens are these ones. Okay, this is the mapped one. I just wanted to map this into an integer, right? 0 to 25, because it's easy, right? In the range of 0 to 25. Just wanted to map this, right? This is just for simplification. We send in the tokens as a list. It's a list, right? So these are new kind of Python syntaxes. Creating a list, we can do it like this, right? So these are actually available in Python 3.11, I suppose. You will be asked about these in interviews. Just go through if you're a Python going to be Python developer, might as well go through the documentation. The Python documentation is the best documentation for any language anywhere except for Rust. Rust is also having some really good documentation, but Python and Rust are the best languages where you can actually learn certain fundamentals of the language easily, because they have spent a lot of time, the creators have spent a lot of time writing um, really great content about the language. Okay, so it's really great. So if you want to become a Python, I think it's given that the future software engineer should be a Python, and at least you have to have a stack of Python and React or something like that, because that's kind of what we are looking for, right? Not traditional stacks. We need more exceptional stacks. How about Java? How about what? I mean, Java in what context? I still don't get it. Documentation. All right. I don't know much about Java documentation, to be honest, because I'm not a Java developer. I have never coded in Java. I don't like it that much personally, so I don't know about that, because there are a lot of versions. Right? You get what I'm saying, right? So version 21 is there. It's different. So yeah, they do a lot of changes, but Python, it's a solid language to get things done. Basically, that's why it's being used. It's the most used language. I'm not saying I'm not discouraging you from not studying Java, because Java is the fundamental language that we see at Altrium also. Instead of the AI part, all the other things are Java. So Java and like this React or something. I don't. That is your passion. That is wherever. What is your end goal of being? If you're gonna be a ML AI engineer or a data scientist, or I mean person dealing with data, of course, you can pursue Python and Rust. If not, a language of your choice, it's Spring, I guess, for Java, right? That would be great. I can imagine the questions that would come at the end, but so to create the frequency of the consecutive, I'm just creating a stat. So when I print the stats, what I get is these are consecutive strings, and I get 1. Okay, these are like these two consecutive number strings, the two numbers, right? First two only once appears only once. These two appears only once, like that. I can just sort it out. Again, these kind of syntaxes, just make sure you guys are familiar with them, right? So again, so here what I have is 101 and 32 have 20 times. They have been together 20 times. Consecutive characters. Only 2. We are only talking about 2, right? 204, it's 15, like that, right? So until 1, you can see. Okay. Okay. So what I'm kind of doing here is I just wrote a program. This is not so I heavily inspired this part of the this part of the workshop with Andre Karpathy's explanation. But this is something I came up with, but it's not really optimal. But I use default dicts, and these are kind of new things. So what basically happens is, so we get a corpus. We get a corpus called lowest, and we like do this kind of pair low, lowest, low, and so like this is, see, this is I mean this is bad, right? This is not good tokenization. We have to do it iteratively. This is just two, right? Two pairs. Okay, so explanation is for you to read. I have added these two as well. Final results are there, only two, but this is not great. This is not great because there are two laws. Right? That doesn't make sense. Anyway, we have this again. There's a huge text which is extracted from a website. Right? And what I'm doing is I'm turning it into tokens. Tokens are just encoding this into raw bytes, and then I'm mapping it into 0 to 20, 225, 55 for convenience. All right, that is just because it will be a huge amount of numbers. We don't need that. Right. So what I do here, this is an interesting function, is I get the stats. So here what I do is I get same thing like this. Okay, this is the same function, same kind of, it does the same thing, this thing, stats. All right, the pairs, I get those values. I get the value and then merge the merge the most occurring ones, right? Okay, sorry, merge the least occurring ones. Like that we can set a vocabulary size. This is the vocabulary size we need, and merges. So that is then how much? 20 merges. So I actually encourage you guys. This is a greedy method. See, so merging 132 into a new token. So it creates 20 new tokens and maps. Instead of these two tokens, we have these 20. Now there are 40. We have 20 now. Right? That's basically what has happened. So the compression ratio is 1.27x. You can see the tokens length previously and the IDs that we have replaced. It has become, this is a really good compression ratio, if you ask me, right? So the code explanation is again get stat merge function, and we get a main loop. Why this is greedy? Okay, at each step of the algorithm, max step, we are just approaching time. I guess a choice based solely on the current state of the ID. So it doesn't know the previous states. So that is the thing. So when solving greedy problems, we just don't know the entire thing, what we are doing actually, right? What we try to do is to create, like we might fail actually. We might fail to compress, all right? That can happen. But the thing with 3D algorithms is we expect, we assume that whatever optimization that we do in the nooks and crannies of the problem will lead to a globally optimal solution. All right, so just read through this, and yeah, that's basically what I wanted to you guys go through you guys, but certain things I just skipped out because you guys are still learning. This tokenization stuff might have been a bit, this greedy might have been a bit taxing for you, but you'll understand this. So so yeah, and by the way, you guys can contact me at, don't spam me for any, this is not, right? This email, write it down. I'm not going to copy and paste it, or this phone number. If you have any queries about relating to machine learning, all right? So yeah, that's it. I just wanted to thank the IEEE computer science student branch chapter of IIT. I also am a member, previous member of IEEE. IEEE is really great. So keep engaging with their tasks. Basically, that is something that I did. I was able to become the webmaster of the student branch when it was at the prime. We were the best student branch in, I can't remember the year. We beat Morato. So you guys are, I think, up to that. That is kind of what you guys are trying to do. I fully wish you the best for that, for the organization. And it's really nice that you guys are doing this kind of stuff. And the participation is pretty good. I mean, I just expected 20 people. To be honest, now still at the end we have 41, which is great. So that means some kind of no, I mean, I didn't waste my time. Basically, that's really great for me. Yeah. So you guys can contact me regarding ML questions, specific ML questions regarding LLMs. I do specialize in diffusion models and LLMs. That those two are my specializations currently. So anything related to those, you can hit me up, send me a message, but don't spam. And also connect with me on LinkedIn. Really? Diverse. Okay, thank you so much for saying that. Actually, I'll send you my LinkedIn link just for you guys. You can follow me on LinkedIn, just search, I'll send you the link. So any questions, please ask now. Any questions not just regarding this seminar, this workshop today, just about generally about if you have any kind of queries about the industry or how it operates or about machine learning, because I'm an engineer. So I'm here to answer for the next 30 minutes, I guess. Please ask questions. Can someone let people speak? I would like to hear your voices. Ask away, because I know you have a lot of questions. How do I get into machine learning or something? Like I could. Okay, I'm just checking out the chat as well. So are there any questions? No? Yeah, you're welcome. It was a bit complex. I knew when I saw the thing. I actually, to be honest, I didn't have much time. We had a small, we had a release in the. Oh, what do you have to study for machine learning as basics? Yeah, study math basically. Study statistics and linear algebra. Those two are the most important stuff in for machine learning, especially linear algebra. The thing is though, not just don't learn things theoretically, right? Try to implement, try to fine tune models, try to understand what a transform is, try to do active stuff, and that's how you get into the industry, right? Not by learning certain stuff. Do you recommend some projects to tell them to? Well, we do have you guys can actually recommend some which in ML and computer vision. Yeah, computer vision is a part of machine learning. So machine learning is this huge thing, right? Machine learning is this huge thing with we have deep learning, which is where AI resides, all the transformers and all that. That is deep learning. Then we have computer vision. So computer vision was traditionally basically not related to machine learning for a long time until like 2015 when convolutional neural networks were discovered. Now we have convolutional neural networks. From there, computer vision is a part of machine learning because convolutional neural networks exist and they are neural networks, which means they are deep learning and deep learning algorithms. And then now we have diffusion models, and vision transformers. So it's like so much bonded together. Computer vision and ML is like computer vision is subdomain of ML. To be honest, it's very well related. If you guys want to learn deep learning, you will at some point we'll have to deal with computation. Yeah, it's exciting, yeah, but yeah, it's an exciting field. So I'm just finding my link. So you guys can find me on LinkedIn if you have any other questions. Or are we gonna end? I didn't check it. What are the softwares you use every day as an ML engineer in the industry? Softwares and tools. So I'm a Linux user. So that means any Python user should be using Linux. There's no point in using else. Mac is fine, I guess, but Linux is great. My flavor is Arch, but anybody can have their own flavors. And the softwares, I use VS Code as my major editor. So how do I get input all the things? So I'll first answer this question. So yeah, that's what I basically do. VS Code, Python, and Rough. There's a linter called Rough. We don't use usually. So you'll learn about linters later on when you learn my stuff. So yeah, it's fun. And Rust as well. So for Rust also I use VS Code. Rust, if you don't know, is a systems level programming language that is much more efficient than it's rivals C in efficiency. So now we are kind of trying to integrate complex machine learning models into Rust because Python is resource intensive. Okay. How do I get into IoT things? IoT, start with Arduino, then go to Picos, I guess. Raspberry Pi Picos, you can do a lot there. ESP is also great. But start with Arduino and start with C. You will have to have a little bit of a knowledge about C, not C++. C. Coding is a little bit ugly, to be honest. C is very long. Any other questions? No. Are we gonna end? If you have any questions regarding this today's session, I mean, please do ask. But I was just planning on going on a little bit further on this byte coding thing, but I guess you guys would absolutely. Wait a second, I'll do it right now. Give me 1 minute. And the software that I use, like for Python, there is this thing called Jupyter Notebooks. You might have heard of this. We use Jupyter Notebook today. It's the best thing, like kind of that happened to Python. So yeah. So to rapidly like prototype things, this is awesome. And for a lot of things, because we can integrate text in Markdown with Python code, it's really great. So it's something that a machine learning engineer should have in their bucket, in their let me give me a second. Today. I'll share this with you as in the viewer. Any other questions? So here's the link. Is Google Colab? It's really great. Google Colab is really great. Google Colab gives you a GPU, right? So it's basically Jupyter, but with you're not running things on your own machine. You're running things within like a cloud computer. So it's wonderful. So for fine-tuning tasks, so personally I use Google Colab. Anything else I don't like. Colab is great. So I shared, I guess you guys can verify if you can see this, if you can see and download it. This is going to be at NBViewer. There is a top link. So I'll share and show you how it works. The link is like this, right? You can just hit download here. You can go to GitHub Gist and view it on Gist as well. Yeah, you can download it and you can run it locally. That's it. Then there seems to be another question. Fine. How I mean Julia's work. So sorry, there are a lot, right? I only have Java knowledge and kind of yes, Java is a good language. That means you have basics of programming. By getting into Python is easy. Just get in and try. You have a lot of years ahead of you. So yeah, I learned Python in 6 months. I'm still learning, but Yeah, it's a continuous learning process, of course. So yeah, yeah, Google Colab that it's great. How am I work with? Yeah, so that's a major issue actually. Software AI ML engineers or machine learning engineers, to be honest, I don't like the AI part. Machine learning engineers are not software engineers who know machine learning. They are a different kind of people. What we do is we bridge the gap between software engineers and machine learning and data scientists. We stand between them. What we do is architect solutions for certain problems. My personal job is to architect, like for example, a chatbot. So if you are gonna create a chatbot, it should be able to deal with any and all adversarial attacks, right? So for example, like that. So what is the best LLM to use? Those decisions are made by AI ML engineers, and software engineers just basically do the rest of the work. For example, if we create the backend for the LLM, they will integrate it with the front end. So for example, OA will integrate it with I mean, basically AI ML nowadays goes as microservices. So it's good to know about microservices, Docker, Kubernetes, and all those things, because a software engineer should be a DevOps engineer. Okay, so there are not things called DevOps engineers. That's a really bad name. Any self-respecting software engineer should know DevOps. So do some stuff on DevOps side as well, on how to deploy things. Yeah. So I guess that's it, right? You guys can contact me personally. The it's not there. Wait a second. I think I may have shared the wrong notebook. The whole thing is not there. Give me a minute. All right, I guess now it should work. And somebody. I'll share the district use of CC. Okay, then I guess that's it. Thank you so much for having me. This was my first this kind of thing that I did. So I guess I did okay, but it was an advanced topic. Hope to do, if you guys, I mean, since I specialize in machine learning, if you guys have any future events, please don't hesitate to ask. Thanks. Thank you so much.
Thank you, Mr. Amod Sahabandu, for sharing your expertise and guiding us. We would like to take a moment to express our heartfelt gratitude to our speaker, Mr. Amod Sahabandu. Your time and effort in leading our fourth workshop in CodeRally 5.0 on advanced programming techniques are greatly appreciated. Thank you for sharing your invaluable knowledge and expertise with us.
Thank you for having me. All right, then.
Last but sorry.
Okay. I'm sorry.
Last but not least, let's acknowledge our valuable title partner, eFutures, who has been with us since the beginning of CodeRally 5.0, providing great support. To capture the lively spirit of our community, let's take a quick group photo. Please turn on your cameras and smile for the picture.